So in this video, we're going to take some things that we learned in previous sections along with one new idea called multiplicity, and we're going to put those ideas together and learn how to sketch the graph of a polynomial. So the three things that we need to know in order to sketch the graph of a polynomial is the end behavior, and we already talked about that. That's what your arrows go on your graph to tell us what happens vertically as the graph comes out all the way to the right and all the way to the left. And your x and y intercepts, those are the values where it crosses the x or the y axis. And the new thing that we're going to learn today is multiplicity. And a multiplicity is the value that tells us how many times a number is an x-intercept. So, for example, if I had the polynomial x plus 3 squared, x minus 1 cubed. If I were to actually expand that out, I would have x plus 3 times x plus 3, because it's squared, times x minus 1, x minus 1, x minus 1, because the x minus 1 is cubed. So when I go to find my x-intercepts, remember the x-intercepts are the value of x when y is 0. So I would plug in 0 for p of x, and I would solve for x. So when I solve that for x, I'm going to get negative 3 and positive 1, because those are the values that I would plug in for x that would make that polynomial 0. So I know that these would be my x-intercepts. However, if you notice, x plus 3 is a factor twice. So that means negative 3 is an x-intercept twice. And that's what we call a multiplicity of 2. And then x equals 1 is an x-intercept 3 times, because I have that factor, x minus 1, 3 times. So that's what we would call multiplicity 3. So that multiplicity tells me the number of times that number is an x-intercept. Now, the reason why we care about multiplicities is that's going to help us determine what happens between the arrows. So the arrows, when we talked about end behavior, tell us where the graph starts and stops when we draw it, okay? But the stuff that happens in between is determined by the x-intercepts and the multiplicity. And the multiplicity helps us determine the behavior of the graph in the area where it crosses over or it touches the x-axis. So the three big multiplicities that we're going to use frequently are multiplicity 1, 2, and 3. I'm not leaving myself enough room. Hold on, let me fix that. So there's multiplicity 2, and then here's multiplicity 3. Okay, so I'm going to show you what the graph looks like when we cross over the x-axis. So imagine that these lines here are the x-axis. I'm going to do one for each example. Okay, and imagine that these red dots, it's the x-intercept. So it's where the graph crosses the x-axis. Okay, so for multiplicity 1, when you have an x-intercept with a multiplicity of 1 and you look at the behavior near where it crosses the x-axis, it's just going to slice straight through. When you look at a graph that and an x-intercept that has a multiplicity of 2, it's going to do what I like to call a touch and turn, where it's not actually going to cross over the x-axis. It's literally going to come up, touch the axis, and bounce back down. And it could come from above too. It doesn't have to be below. It could come from above, where it could come down and bounce back up. With the multiplicity of 3, it's gonna cross over the x-axis, but when it does, it's gonna make kind of a swirly motion. I know that's not the best mathematical terms, but that's the best way I can describe it. So when it crosses over, it's gonna kind of do a swirl. It's not gonna be like a straight slice straight through like a multiplicity of 1. And if you want to look in the book, it does a much better job of drawing those pictures for you than I can draw, because I'm not the best artist. So this helps us see what happens around the x-axis when we graph an x-intercept and we want to draw the entire polynomial.